Okay. Good evening, everyone. Hello, good evening, everyone. Am I audible to everyone? Good evening, everyone. Okay. So, today we are going to start with the good evening, Bharti. Good evening. Good evening, Anushka. Good evening, Sanjana. Okay. Okay, so today we are going to start with the electronic configuration. Okay. So in the electronic configuration, what we saw in the last class, I'll ask you one question. Okay, come to this. So let us say principal quantum number n ka value is equal to 3. So for n is equal to 3, give me L values quickly. Give me L values for n is equal to 3, guys. Give me L values. For n is equal to 3, what will be the L possible values? Please give me the L values. Give me the L values, guys. N is equal to 3, what will be the L values? No, total. 0, 1, 2, very good. Lakshmi, Anusa, very good. 0, 1, 2, very good, beta ji. No, beta ji, minus 3, that is the ML values. Okay, so L value varies from 0 to n minus 1. L vary 0 to n minus 1. So this will be 0, 1 and 2, right? Now for 0, what is the shape? For L is equal to 0, what is the shape? Bolo beta ji, L is equal to 0, which orbital? Which subshell rather? S. For L is equal to 1, which subshell? P. For L is equal to 2, which subshell? D. Yes or no? SPD. Okay. So now my question is, from all of you, my question is, let us say we are in the third orbit. Acha, one more thing, I'll go with this quickly. So let me put it like this. Let us say n value is 3. So L values will be L values 0, 1 and 2. Relation between quantum numbers and orbitals, right? So what will be ML values? So L 0, 1, 2, ML values for 0, 0. ML value varies from minus L to plus L. So this will be minus 1, 0, plus 1. Yes or no? And for 2, this will be minus 2, minus 1, 0, plus 1 and plus 2. Okay. Now, so what are the orbitals? For this n is equal to 3, L, S subshell, ML 0, that means only one orbital, that means 3s. So what is the representation of S? So this is represented like this. S orbital means one dabba. So this dabba, this square we are forming, this is called as orbital. This is called as orbital, and one orbital will only contain 2 electrons. This is the how we are going to represent one orbital, not orbit beta ji, not orbit, I'm not saying orbit. One dabba, orbital. One orbital will only contain 2 electrons. Okay, so what is the symbol for these ones, bolo beta ji? For these ones, Px, Py and Pz, isn't it? Px, Py and Pz. So what are the number of orbitals? Px, Py, Pz. So for P subshell, 3 dabba will come. 3 orbitals. Px and bolo beta ji, Py and Pz. 3 orbitals will come for P subshell, isn't it? For P subshell, this is subshell beta ji. This subshell, these are the orbitals. X, Y, Z. Because I have put the orientation, now they are the orbitals. Specific orbitals. If I am saying only P, it represents subshell. But in subshell, we have orbital. So this is n value, this is shell value. And these are the subshell values. L value means subshell value, P. And in P, we are having different orbitals, which is Px, Py, Pz. So now P subshell have 3 orbitals, Px, Py and Pz. So this is how we represent that. Okay. Now D, so 2 represent D subshell. So this is D subshell, and D subshell will have 5 set of orbitals. So how we are going to write? These are the 5s, 1, 2, 3, 4 and 5. So these are the 5 set of orbitals, and you know the names dxy, xz, yz, like that we have the names. So for D subshell 5 orbitals, for P subshell 3 orbitals, and for this one, this is called as 1 orbital. Acha, if their energies are same, if energies of orbitals are same, if energies of orbitals are same, they are called as degenerate orbitals. If the energies of the orbitals are same, they are called as degenerate orbitals. Degenerate means same energy orbital. Degenerate orbitals. They are called as degenerate orbitals. Okay, is this clear to everyone? Just give me a thumbs up. Everyone, just give me a thumbs up. Is it clear to everyone? Should we go ahead? Is it clear to everyone? Give me a thumbs up quickly, guys. Is it clear to everyone? Okay, very good. So now I have a very good question for you. This is the question of JEE Advanced. JEE Advanced, I think 2021, this question came. The question was, what is the total number of degenerate orbitals in third orbit for lithium 2+. So this is the question. Total number of degenerate orbitals in third orbit of lithium 2+. Can you give me the answer for this? Total number of degenerate orbitals in third orbit for lithium 2+. This is JEE Advanced ka problem. Can you give me the answer? Total number of degenerate orbitals. Let me see if anybody can give the right answer. 5, no, 5 is not the answer. 5 is not 10, 10 is not the answer. Total number of degenerate orbitals. Let's see how much talented you guys are. Degenerate orbitals. No, total number you have to tell. 10, 3, 0, no, 14, no. Third orbit, no, 0, 8. Okay, somebody said, who was that? Somebody said 9. Who was that? Who said 9, guys? Somebody said 9, huh? 18, 4, 143, 2, 8, 2, 3, 18, no, 14, 17, 9. Sanjana has said 9. All of you have started to say 9 now, huh? Because you have realized that sir is saying 9, so answer should be 9, huh? Achha, can anybody write why 9? Can you write why 9? Just write the answer why 9. Write just 1-2 line explanation for 9, why it is 9. Just write why it is 9. Huh? Anybody can write the reason for that. Just write the reason. 1 or 2 lines reason. Because I told. How I told? Yes, because of 3 square. Arey idiot Ravindra. 3 square. Third orbit means. Can you give me the subshells? Can you give me the subshells of third orbit? Can you give me the subshells of third orbit? Yes, S has 1, P has 3, D has 5. Naral Santosh, very good beta ji, very good. Very good. +2 charge no. It has not 3S, 3P, 3D. Yes. Okay. Now you see lithium 2+. Okay, let me come like this. So there are 2 kinds of system. Listen beta ji carefully. Monoelectronic system and many electron system. Single electron and many electron system. In single electron system means hydrogen, helium+, lithium 2+, beryllium 3+. Now in these, there is no penetration or shielding. There is no penetration or shielding. That means nobody is going to penetrate. And if penetration will not happen, shielding will not happen. Because once s orbital is penetrated, it is going to shield the nucleus. Shielding ka matlab repulsion beta ji. So if penetration will not happen, shielding will not happen. So basically shielding is the consequence of penetration. And penetration will only happen if there is competition of 2. If there is single electron, no penetration ka concept, isn't it? So single electron atom, no penetration and no shielding. Therefore, S and P ka energy will be same. S and P and D ka energy will be same. So if you have third orbit, so n is equal to 3. For n is equal to 3, L values 0, 1, 2. L value is equal to 0, 1, 2. That means 3s, 3p and 3d. For 3s, how many orbitals? 1. S के लिए 1 orbital. For p, how many orbital? 3. And for d, how many orbital? 5. I can write like this. Look at this. So this is nucleus, beta ji. This is nucleus. As you go away from the nucleus, energy increases. As we go away from the nucleus, energy increases. So 1s, rather I'll write third orbit, so 3s. Then what will come, beta ji? 3s. What will come? If you start from the ground state, actually, if you start from the ground state, you can start like this. Start from the ground state. So this will be, dekho beta ji, 1s, first orbit, n is equal to 1. In 1, we have only s. N is equal to 1, L is equal to 0, only 1s. Then what will come? What will come, beta ji? 2s. And 2s के बाद क्या आएगा? 2p. And 2p में how many orbitals do we have? 3. So all will have same energy for single electron. For single electron, all will have same energy. Then what will come? Third orbit. Third orbit में क्या है? 3s. And then we have, बोलो बेटा जी, 3p, 3s and 3p. Then what do we have? 1, 2, 3, 4 and 5. 3d. So these are 5 set of orbitals. 3d. These are the 3p and this is 3s. If you go to fourth one, that will be 4s, 4p, 4d and 4f. So answer will actually become 9 plus 7 is equal to 16. So these are called as degenerate orbitals. These are called as degenerate orbitals. Degenerate orbitals means same energy. So this question is very famous. This has been asked so many times. So for single electronic system, there is no concept of penetration and shielding. And because there is no concept of penetration and shielding, in the same orbit, all the subcells and the orbitals will have same energy. All the subcells and all orbitals will have same energy, isn't it? So they will have same energy. But if you go to multi-electronic system, now the energy will be different. Because of the concept of penetration and shielding, we learnt in the last class. What is there to explain, beta ji? I told you in the last class, let us say this is 2s and 2p. This is 2s and 2p. So what will happen? S ka penetration will happen in multi-electronic system. Multi-electronic. S ka penetration will happen once S has come closure. Once S has come closure. S has come closure. Now this is electron. This S orbital is filled with electron, as well as the outer p orbital is filled with electron. This outer p orbital is filled with electron. What will happen? Once this S comes inside, this will kick. This will kick what, beta ji? P orbital. This will start to kick p orbital, beta ji. P orbital. This is p orbital. This will start to kick p orbital. So p orbital goes outside. P orbital goes outside. That means p ka energy become more than s. As you are away from the nucleus, your energy increases. Shielding will form. Yes. Shielding of what? Shielding of the nucleus. S orbitals come closer. S orbital come closer. Seals the nucleus. Why it is shielding? It is start. Let us imagine like this. Let us say you have some favorite actor or something like that. Okay. So whom do you guys like? Any actor? Give me any actor name whom you guys like too much. We can explain that example. Any actor name whom you think? Nani? I don't know South Indians names. Okay, Rohit Sharma. Okay, so we'll take the example of Rohit Sharma. Okay, let us say NTR, Prabhas. Oh my God. Okay, so Virat Kohli. Okay, so let us say Virat Kohli is there. Now this is the nucleus which is Virat Kohli. This is the nucleus which is Virat Kohli. And now there are two people. Let us say we'll take one example. Okay, who is there? Let us say I am there and my friend is there. Okay, two people are there. One is s orbital and one is p orbital. Initially both are having same energy. Isn't it? So once I got the opportunity to go closer to Virat Kohli because I am a big fan. I'll go closer. Once I go closer, what will happen? Once I go closer to the Kohli, now I won't allow anybody else to come because I want to shake my hand, I want to meet to him, I want to talk to him. So what I'll do is, I'll kick others. Go outside. Let me meet, isn't it? That is the kind of nature we are having. Because electron and electron repel each other. Electronic repulsion will happen. Therefore, what will happen? This s orbital will actually come away because of repulsion between the penetrated s orbital. Therefore, repulsion will happen, energy will increase. So, how do we measure that energy? So, that energy is measured with the help of N plus L rule. For example, 2s and 2p initially having same energy, but S got attracted, so 2p energy increased. So, how come we can use the formula N plus L? You see N plus L value. N plus L value for 2s is equal to 2 plus 0 is equal to 2, and N plus L value for 2p is 2 plus, what is the L value for p? 1. So this is equal to 3. So 3 is more than 2. That means 2p energy will be more than 2s. On this N plus L rule, I have a table for you how to do it. Please listen carefully, beta. This is very, very important to understand the configuration. So 1s, 2s, 3s, 4s, 5s, 6s and 7s. We know that for first orbit there is no p orbital. P orbital start with 2, so there is 2p. Then there is no 2d because we know that for n is equal to 2, L value is equal to 0 and 1, so it is only p. There is no d orbital, there is no d subshell. Similarly 3s, so 3p and 3d, isn't it? For 4, there will be 4s, 4p, 4d and 4f. Similarly 5s, 5p, 5d and 5f. Similarly 6s, and then 6p and 6d, and for 7, 7s and 7p. Now you see what is the help of N plus L rule. देखो बेटा जी, ध्यान से देखिए everyone please. I want your 100% focus बेटा जी, ध्यान से देखो. So 1s start with 1s. Why 1s? Because N plus L values minimum. What is that? 1. After 1s what will come? 2s or 2p? After 1s what will come? 2s or 2p? Give me the answer guys. After 1s what will come? 2s or 2p? Arey beta ji, you can have 5s, 5p, like that it can go further, but we don't need that actually because yes, 2s. So 2s will come first and then 2p will come because 2p ka energy is higher. Because 2p ka energy is higher, isn't it? So after 2s what will come? 2p. 2p ke baad kya aayega? 3s. After that what will come beta ji? 3p. You see, now we are having, idhar dekho beta ji. After, idhar dekho aise ja raha hai. This is going like this, aisa. So once you fill 1s, you go to 2s, then 2p. Because in 2s and 2p, 2p ka energy is more. So first we'll fill 2s and then we'll go to 2p. 2p. After 2p what will come? 3s, 3p, 3d. What will come? N plus L value. 3s ka N plus L value 3. 3p ka N plus L value 4. Isn't it? And 3d ka N plus L value 5. So lower energy 3s. After 3s what will come beta ji? 3p. Isn't it? So 3p and 4s. Now I have a doubt, sir. I have a doubt, sir. What is doubt? Doubt is, sir, tell me 3p and 4s. What is the N plus L value, sir? What is the N plus L value for 3p and 4s? What is the N value for 3p and 4s? Bolo beta ji. N plus L value 4, 3 plus 1 4 and N plus L value 4. Oh my God. Both are having same N plus L value. Both are having same N plus L value. Now what to do? Was both are having same N plus L value. Now what to do? Now remember, you always go with lower orbit because lower orbit ka energy will be less. When we get same, idhar go, for same N plus L value, for same N plus L value, prefer lower N value. Prefer lower N value. That means in 3p and 4s, I am going to prefer 3p. So first lower energy will be 3p and higher energy will be 4s. So if N plus L value are same, you prefer the lower N value because energy will be less. Okay. Then what will come beta ji? 3d and 4p and 5s. So like that it will come. Okay. So you can match like this. Like this we can do it. Okay. So this is how it is done. So first you fill the 1s orbital, then you go to 2s orbital, then you go to like this. ऐसे जाना बेटा जी, ऐसे. Then you go to 2p orbital, then we go to 3s orbital. Then after 3s we'll go to 3p orbital. After 3p we'll go to 4s orbital. Again after 4s what will come? 3d. Now we'll go to 3d orbital because 3d ka N plus L value 5. 3d and then what will come beta ji? Like this will continue. So this is how we are going to fill the electron. This is how we are going to fill the electron. Is this clear to everyone? Just give me a thumbs up, guys. Is this table clear to everyone? Give me a thumbs up. Is this clear to everyone? This table is clear to everyone? Bolo beta ji, everyone. Okay. Okay. Very good. Now, n plus l means bolo beta ji addition कर रहे हैं. n मतलब principal quantum number, l plus azimuthal quantum number. You add that values, lower n plus l value, lower energy. That's all. Lower n plus l value, lower energy. N means principal quantum number, l means azimuthal quantum number. Okay. Now, to understand electronic configuration, we need few rules. We need few rules to understand electronic configuration. First rule is Pauli's exclusion principle. Pauli's exclusion principle. Pauli's exclusion principle. What is Pauli's exclusion principle? It says that no two electrons can have all four quantum numbers same. All four quantum numbers same. What is meaning of it, sir? Explain me the meaning of it. Okay, let us come to the meaning. Example. Let us say I am writing helium. So helium ka atomic number is 2. So number of electron 2. 2 electrons. So how we will write? Starting with 1s. Starting with 1s. So I'll write 1s2. 1s2. Now, how to represent this, sir? How to represent this, sir? Okay, how to represent? So first orbit, S value 1 electron and 1 electron. You can represent like this, or you can represent like this. There are two ways to represent. Either I can represent like this, or I can represent like this. So how should I represent it, sir? Now this is very, very important, and this is the meaning of Pauli exclusion principle. So according to Pauli's exclusion principle, no two electrons can have same quantum numbers. All quantum numbers cannot be same. Now let us check the quantum numbers. For this, what is n value? Okay, let us check for both electrons. For this electron, left-hand electron, what is n value? Principal quantum number 1, n is equal to 1. S orbital, तो L value कितना हो गया बोलो बेटा जी? 0. L value is equal to 0. Yes? N is equal to 1, L value is equal to 0. Okay, what else, sir? We have n value, L value. What is ml value? For L is equal to 0, ml is equal to 0. Isn't it? Spin is plus half. You remember? This is minus half, this is plus half. So spin value, spin magnetic quantum number is equal to plus half. Now, let us check everything for second electron. Let us check everything for second electron. You look for the second electron. What are the principal quantum number? 1. L value 0. ml value 0. Principal quantum number plus half. Oh my God. Both things are same. Both values are same. That means this configuration is not correct. This configuration is not correct. We need to have opposite spins. For opposite spin, the remaining 3 quantum numbers will be same, beta ji. Remaining 3 quantum numbers will be same. What will be different? Spin quantum number. Spin quantum number will be different. For example, for this one, spin will be plus half. And for this one, spin will be minus half. Isn't it? That means quantum numbers are different. So this is called as Pauli principle. In Pauli principle, no two electrons can have all the 4 quantum numbers same. What it means is, it means in an orbital, you can never fill the electron like this or like this. Whenever we fill the electron should be always filled with opposite spin. It should be always filled with opposite spin. Okay, I can go more in detail. There is something called as magnetic property, this and that. I don't have much time. If I'll have time, I'll explain you. For now, this is it. I'll explain quickly. What is diamagnetism and what is paramagnetism? Paramagnetism and diamagnetism. Diamagnetism means if you throw an object into the magnetic field, repulsion will happen. What is paramagnetism, sir? What is paramagnetism? If you throw paramagnetism. If you throw an object into the magnetic field, attraction will happen. Diamagnetism, repulsion happen. Paramagnetism, attraction happens. If the electrons are paired, इधर देखो बेटा जी, if electrons are paired, it is like this. Idhar dekho. So this is, let us say, north and south, and this is north and south. Now both poles are supporting each other. Both poles are supporting each other. Because they are supporting each other, actually they are going to attract into the magnetic field. More magnetic field, if you put into the magnetic field, attraction will happen. Therefore, they need to be having opposite spin. Opposite spin means what, bolo beta ji? North and south and north. Now, these electrons cancel their magnetic field. Because they are cancelling their magnetic field, therefore it will appear as diamagnetic. And this is the experimental observation that whenever the electrons are paired, whenever the electrons are paired, whenever the electrons are paired, they always show repulsion in magnetic field. They always show repulsion in magnetic field. Therefore, it is very, very important that electron, if they are paired, there should be opposite spin. Otherwise, same spin, actually they will show attraction, which is not true. So, always you have opposite spin. So, this is Pauli exclusion principle. Okay. Now, let us come to the next one. Next one is called as Hund's rule. Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity. Okay. Now, let us say that I want to write electronic configuration of carbon. Electronic configuration of carbon. How to do it, sir? How many electrons are there, beta ji? Carbon is equal to how many electrons? 6 electrons. Okay, so how to start, sir? Start with 1s, then go to 2s, then go to 2p, and one orbital, 2 electrons, isn't it? Okay, let me write like this. So I'll write 1s, 2s, 2p, 3s, higher energy, increasing energy order. So in 1s, how many electrons will be present? In 1s, 2 electron. 1 dabba, 2 electron. 2s, 1 dabba, 2 electron. 2p, how many dabba? 3 dabba, so 6 electron. One orbital contains 2 electron, total 6. But how many do we have? Only 2. To fill those 2 electrons, 1s2, 2s2, 2p2. Now how do we represent? Let us look at this one, beta ji. ये तो मेरे को समझ आ गया. This I have understood कि spin should be opposite. Spin should be opposite. This I have understood. Spin should be opposite. Spin should be opposite. But what about this one? If I look at the 2p, how to write 2p2? How to write 2p2? That is my question. How to write? Possibility. First possibility is I can write the 2p like this. One possibility. And it does not violate Pauli principle. According to Pauli principle, it is okay, isn't it? Okay, what is the other possibility? Other possibility might be, sir, I can represent like this also. One possibility, isn't it? Again, it doesn't violate Hund's rule, because according to Hund's rule, no 2 electrons can have same spin in the same orbital. They are in different orbital. Different orbital means what? Let us say ml values. For this ml value -1, 0 and +1. So they are having different quantum numbers. ml value different. So different quantum numbers. Very good, very correct. What is the other possibility, sir? I can have this representation. Half, -half, like this. Now the question is, sir, which is correct, sir? According to Pauli, this is also correct. This is also correct. Sorry, this is also correct and this is also correct. Because according to Pauli principle, in one dabba, spin should be opposite. In one dabba, spin is opposite. Because they are in different orbital. They already have different quantum numbers. So I don't care about Pauli. Pauli is already correct. So sir, tell me which is correct then. Correct configuration is this one and these two are incorrect. Correct is this one. Why it is correct, sir? Why it is correct? Because in this case stability is maximum. Actually, there is a concept of quantum mechanics which is called as spin correlation. There is a concept in quantum mechanics. We are not going into quantum mechanics anyway, but there is a term called spin correlation. So if the unpaired electrons, if the unpaired electrons are having parallel spin, they are more stable. Parallel spin, they are more stable. Why it is more stable? Right now I don't have time. I don't want to go into that, but they'll be more stable. Sir, you told what is maximum multiplicity, sir? You told maximum multiplicity. Can you explain me what is maximum multiplicity? Yes, I can. Look into this. So what is spin multiplicity? So this is capital S. This is called a spin multiplicity. Spin का multiple times, spin multiplicity. Spin multiplicity का formula होता है बेटा जी, S is equal to 2S plus 1. Spin multiplicity is equal to capital S spin multiplicity. Small s is called a spin value. Small s is called as spin value. Small s is called as spin value. Now, in these three, which is having maximum spin value? In these three, which is having maximum spin value? Okay, let us check. Which is having maximum spin value? Let us check, beta ji. Small s. So what is small s for this one? Plus half. Acha, and minus half. Kitna aa gaya bolo? 0. Spin value in the first one, 0. In second one, what is the spin value? Okay, sir, plus half. Very good, plus half. बहुत बढ़िया. Total kitna aa gaya? 1. What about this one? In this case, spin value is how much bolo beta ji? Plus half. And minus half is equal to 0. Oh my God. So what is the most correct one? Maximum spin value. Maximum spin means what is capital S? 2S plus 1. Capital S beta. 2S plus 1. So 2 into 1 plus 1. This is equal to 3, sir. And what about this one, sir? This is capital S is equal to 1. According to the formula. According to the formula. See, this is small s. Capital S spin multiplicity. Small s spin value. What is spin value? Add the spin ka value. Plus half, minus half, plus half, whatever, add it. So plus half, 1 spin multiplicity 3. What is spin multiplicity for this one, bolo beta ji? Plus half, minus half, 0. So spin multiplicity 1. So in which case we are having maximum. Hund's rule of maximum multiplicity. Hund's rule of maximum. Ye minimum, this is maximum. So Hund's rule of maximum multiplicity. So this configuration is correct. This configuration is correct. How many of you understood Hund's rule? Give me a thumbs up, guys, quickly. How many of you understood Hund's rule? Give me a thumbs up, please, everyone. Let's see how many of you understood. Give me a thumbs up, guys. 3 understood. Everybody else, please give me a thumbs up, guys. Let's see how many of you understood. Okay, great, guys. Great. Very good. Very good. Okay, very good. Now, once we have understood the Hund's rule, now we want to understand the third rule, which is called as building block principle. Which is called as building block principle, which is known as building block principle, which is nothing but n plus L rule. This is also called as Aufbau principle. Aufbau principle. This is also called as Aufbau principle. According to Aufbau principle, electron must be filled in lower energy first. Must be filled in lower energy first. This is called as building block. How we build the building with the blocks? कैसे block रखोगे? Are we directly going to form the third floor? Obviously not. We are going to form the ground floor, then first floor, then second floor, then third floor, then fourth floor, isn't it? Potential energy increases. So we always start with the ground state. You always start with the minimum energy and then you keep on increasing the energy. This is the meaning of building block principle. For example, let us say that I want to write the carbon, or let us say oxygen. Oxygen ka total electron 8. How to write? So we have 1s, 2s, 1s, 2s, 2p, like this. So we have 1s ka dabba, we have 2s ka orbital, and we have 2p subshell ka orbitals. Now, how to start filling the electron? Should I directly go to second orbit? No. Second orbit nahi jana hai. First we will fill the first orbit, then we will go to the second orbit, then we will go to the third orbit. So Aufbau principle is nothing but following n plus L rule. Aufbau principle is nothing but following n plus L rule. Okay. So how to do the configuration then, sir? Very easy. Start with 1s. How many electron ek dabba could have? 2 electron. Remember Pauli principle. Electron ka spin should be opposite. Electron ka spin should be opposite. Okay. What about the 2s, sir? Again 2 electron because 1 orbital. I'm not saying orbit, beta ji. 1 orbital. One orbital can have 2 electrons. Orbit can have how many electrons? 2n square. One orbit can have 2n square. One orbit can have 2n square. So, okay. For example, you have second orbit. Second orbit में maximum electron is equal to 2 to the 4 to the 8. In second orbit, maximum electron could be, I'll write this formula, okay, for you. Maximum number of electron in an orbital. Maximum number of electron in an orbital is equal to 2. Okay. Then, sir, what about orbit, sir? Okay. So, maximum number of electron in a given orbit is equal to 2n ka square, where n is the given orbit. Where n is bolo beta ji given orbit. Okay. For example, second orbit, maximum electron could be 8. Okay. And 2n square. Okay. Now, let us come to this. So, how to fill the electron, sir? Tell me, sir. Don't waste my time. Tell me how to fill the electron. Okay. So, 2p can have maximum electron 6. 2 in this dabba, 2 in this dabba, 2 in this dabba. We can have maximum 6 electrons. But how much is required? 4. Fill the 4. Starting with 1. Now, should I pair it? No, I will not pair it. Hund's rule of maximum multiplicity. First, I'll fill all the electrons unpaired. Once they're unpaired, then I'll start pairing, sir. Hund's rule I need to follow. So, first, 1, 2, 3. 4 plus 3 is 7. Once you have filled the unpaired, then you start pairing. And while pairing the electron, remember, what to remember? Hund's rule ke baad what to remember? Pauli principle. If you are filling the electron, they should be of opposite spin. They should not be of same spin. They should be of opposite spin. Yes, 1s2, 2s2, and 2p4. How to write 2p4? This is the way how we are going to write. Let us take one more example. Okay, let us fill, what to fill? Okay, let us say phosphorus. So, phosphorus ka atomic number 15. And we know that for the neutral atom, number of electron is equal to number of proton is equal to atomic number. Very good. So, we are having 15 electron. Beta ji, chaliye, write the configuration, everyone. Please write the configuration for phosphorus. Write the configuration, please. Write the configuration for me, guys. Write the configuration. Write the configuration. Phosphorus. Write the configuration, everyone. Let's see. Write the configuration. Phosphorus ka configuration. (15 electron). How we are going to fill the 15 electrons? 1s2, 2s2, 2p6. Yes, 10 electrons. Then 3s2, 3p3. Very good, beta ji. Very, very good. Very, very good. Akshat, somebody. Pawan Rama. Okay, very good. बहुत बढ़िया बेटा जी. चलिए. See, so following all the rules, 15 electron I have to fill. So as I told you, n plus L rule. As you remember this table, I think all of you remember this table. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. See, if you ever get confused, what should come first? 3p should come first or 3s should come first. Don't confuse beta ji. Simply add n plus L value. N plus L value. For example, for 3p, n plus L value 4 and 3s 3. So what should come first? Lower number. Lower number should come first. Always lower number should come first. If n plus L value same, for example, 3d and below 4p. 3d and 4p. Now, what is n plus L value? N plus L value is equal to 4 plus 1, 5. For d, what is L value? 2. So 3 plus 2, 5. This is 4 plus 1, 5, and this is 3 plus 2, 5. Okay, sir, both are having same energy. How to start? Start with lower number. What is the lower number? 3d and then 4p. So first you fill 3d and then you go to 4p, because 4p ka energy is more than 3d. Because 4p ka energy is more than 3d. Great. Chalo, let us do the phosphorus then. In case of phosphorus, 1s, how many electron? 2. 2s, how many electron? 2. After 2s, 2p. So 2p, how many electron? 6. Kitna ho gaya? 10. Then 5 electrons are remaining. 2p के बाद क्या आएगा? 3s. 3s contains 2. 3s के बाद क्या आएगा? 3p. Very good. So 3p. So this is the electronic configuration. Sir, how do you write an orbital, sir? Show me orbital ones. Okay, let us see the orbital ones. So 1s में कितना आ जाएगा? 2. 2s. एक डब्बा में कितना इलेक्ट्रॉन? 2. 2p. p subshell contains 3 orbital. So पहले बेटा जी unpaired. First unpaired. पहले unpaired. Hund's rule. Unpaired. Then paired. Okay, sir. Pairing with opposite spin. Following which principle? Pauli exclusion principle. Very good. Then 3s. One dabba. Opposite spin. 3p. Next energy level 3p. 1, 2, 3. Okay, so this is the configuration. How many of you understood the configuration, beta ji? Bolo, give me a thumbs up. How many of you understood configuration? Is it clear to everyone? Give me a thumbs up, guys. Is it clear to everyone? We'll do some difficult ones now. We'll go for some difficult configurations now. Is it clear to everyone? Bol do beta ji, is it clear to everyone? Okay, is it clear? Great, guys, great. Okay, I think all of you have understood the configurations. Okay. Okay, great, guys. Okay, now let us say, acha, one more thing. Whenever we are doing configuration, let us say you want to do the configuration of chlorine. Chlorine ka atomic number 17. So you don't need to write all this configuration. See, ये configuration जो है बेटा जी, this is actually neon का configuration. And neon is a noble gas. All of you know the noble gas: helium, neon, argon, krypton, and xenon. Right? So 2, 10, 18, 36, 54, like that, 86. So when we have already written 10 electrons, no need to write 10 electrons. What we will do is, we'll write the noble gas core in the square bracket. We will write the noble gas core in the square bracket, and then what is remaining? 3s2 and 3p3. Like that. For example, if we have to write chlorine, chlorine contains 17 electrons. Chlorine contains 17. So already we have neon. No need to write that. Neon, which is 10 electron, which finishes as 2p6. So what will start then, bolo beta ji? 3s2 and bolo beta ji 3p5. So this is 10, and 10 plus 7, 17. We should have opposite spin in one orbital. Yes, definitely we should have opposite spin. Opposite spin is 3p7. Anusha, who is Lakshmi? 3p7 beta, p में 6 electron is max. How can you have 7? Yes, neon 3s2 3p5. Neon 3s2 3p5. Chalo, I have one more. What about chromium? Chromium का atomic number is 24. Chromium का atomic number is 24. Difficulty, okay, difficulty. You have the question. Chromium का electronic configuration. Please write the chromium का electronic configuration. Let us see how many of you can write chromium का electronic configuration. Let's go for that. Chromium. Bolo beta ji, give me the answer for chromium. Write the configuration for chromium. Let's see how many of you can do it. Okay, 3d5. Somebody knows that. Very good, Krishna. 3s1. Argon 4s2 3d4. Okay, somebody is saying argon 4s2 3d4. 3d4 nahi, this will be 3d5. Some of you are saying, dekho. So 1s, okay, so argon already contains 18 electron. How much are remaining? 6. 6 are remaining, right? So now after argon what will come? 4s will come. So this will be 4s. In 4s and 3d, which is having more energy, n plus L value, 4, n plus L value 5. So first we'll fill 4s, 4s2, okay. How many are remaining? 4. So 3d4. But actually this is not correct configuration. Correct configuration is 4s1, 3d5. 4s1, 3d5. 4s1, 3d5, this is argon. 4s1 3d5. So actually one electron goes from s to d. One electron goes from s to d. One electron goes from s to d. Why it goes, sir? Why it goes? I have already told you, beta ji. I have already told you. What I have told you? Look into this. So 4s2 एक डब्बे में 2 electron, and d एक डब्बे में कितने electron? Okay. So 1, 2, 3, 4. I have told you, if somehow you can increase the spin multiplicity, if you can increase the spin multiplicity, stability will increase. So what I'll do is, I'll transfer this electron because their energy is similar, not much difference in the energy. So this electron will go over here, और ये एक हो जाएगा और ये हो जाएगा unpaired हो गया 1 2 3 4 and 5. Spin value increases, stability increases. Stability increases. Basically, there is a concept of exchange energy, which will study in 11th class. Okay. So because of exchange energy, actually this electron will exchange. Let us say 4 of us are sitting. 4 of us are sitting. I can exchange my seat with my friend, with my friend, with my friend. So if I'll exchange the seat, energy will be loosening up. Once energy releases, stability increases. Stability increases, isn't it? Okay, very good, sir. Stability increases. So if I can transfer one more electron, more exchanges will happen. More exchanges will happen, stability will increase. Basically, spin multiplicity will be more. I can't go more in detail for now. Okay, you'll study in 11th class. There are some more concepts involved into it. Okay, so thank you guys from my side. Now what you do is write the electronic configurations for atomic number, let us say 10 to 50. Write the electronic configuration for the atoms, atomic number 10 to 50, and the difficult atomic configuration which are having some exceptions. Those will be explained later in your classes, 11th class. For now, we won't go into that. Thank you so much, guys. Thank you from my side. Bye-bye, everyone. I hope you enjoyed the class. Okay. Thank you so much. Bye.